In the last video, we calculated the probability of us choosing a point at random being in this blue region here, and we found that to be 15.625%. And in the beginning part of that video, I said that this probability calculation is a weighted average calculation. But when you look at what we first learned about when we introduced a weighted average, that these integrals here in the numerator and the denominator have the same limits of integration. But notice, our probability calculation doesn't have that. So what's going on here? How can we still claim that this probability calculation is a weighted average? And really, the key to seeing this is understanding what f of x is. What f of x is in this probability calculation. And that is, f of x is a piecewise function. So f of x is going to be defined as this. It is a piecewise function. And in the area, in the region that we're interested in, so that's when x is greater than 1/2, f of x is going to be 1. And then when x is outside of this region, so when x is less than or equal to 1/2, f of x is 0. So that is f of x. So now what we can do is rewrite our probability calculation to make it look more like a weighted average in the way that we first learned it. So we can say that the probability that x is greater than 1/2 is going to be equal to, and now we're going to write this. We're going to say the definite integral, let's make that neater, the definite integral from -1 to 1/2 of f of x, and then we're going to keep what we have over here. This is our weighting function, so 1 minus x squared, and then dx, and then we're going to add onto this another definite integral. So now we're going to say the definite integral from 1/2 to 1 of f of x, and then we still have 1 minus x squared dx. And then we divide by, when we have the same definite integral in our denominator. So this is divided by definite integral from -1 to 1 of 1 minus x squared dx. 1 minus x squared dx. And this is just the entire area under this curve here. So this is the exact same thing as what we wrote in the last video, but we need to notice something. So this is, now it's starting to look more like a weighted average, and this is how we can write out a definite integral for a piecewise function. And notice, when we're outside of our area of interest, out of our region of interest, f of x is what in this region here? F of x is 0. So essentially, this definite integral here is taking 0 and it's weighting it with a little piece of area. And that's just going to be 0 times something, and adding up all of those things, that just goes to 0. This just goes to 0. And then this integral over here is really what we have up here. That when we're inside of our region of interest, it's going to be 1 weighted with a little piece of area. So that is exactly what we have up here. And we already said earlier that this integral in the denominator is the exact same. So now you can see that this really is a weighted average calculation.